Hi everyone, today we're going to be summing a geometric series, both the finite and infinite variants. So let me set up the situation for you. What we do first is that we fix b and r in the real numbers, where b is called the initial term and r is called the common ratio. And what we have is a sequence of the following type. We start with b, then we multiply by r, then we multiply by r again to get br squared, and we keep going until we have br to the n, and in the infinite variant we actually just keep going. So the sum or series counterpart of this is b plus br plus br squared all the way through to br to the n, and the infinite variant of it goes like this: b plus br plus br squared and off to infinity. And really this is a limit as n goes to infinity of the first one. So we take a finite sum and we take the final exponent n to infinity. But we'll deal with that after we deal with the finite variant over here. Let's focus on the finite variant. What we'll do is that we'll do something like what Gauss did with an arithmetic series, but it is slightly different. First step is to let x equal to b plus br plus br squared all the way through to br to the n. And what we want is something that's a little different but has a lot in common with x. So we do x times r, and that gives us br plus br squared all the way through to br to the n plus br to the n plus 1. And then we'll subtract the two. And what we get is x minus xr is equal to, well, these two terms cancel out, these two terms cancel out, and all the way through to this they cancel out. So what we're left with is b minus br to the n plus 1. And now let's factor both sides. So we get x times 1 minus r, which is equal to b times 1 minus r to the n plus 1. And what we'd like to do now is isolate x by dividing by 1 minus r. But notice that the only way we can do it is if r is not equal to 1. But that's actually not a problem, because if r is equal to 1 in the series over here, then all the terms are equal to b. So the sum is just b times n plus 1 because there are n plus 1 terms. So it's actually easy to evaluate in the case that r equals to 1. So we will not worry about that. We'll just assume that r is not equal to 1. And what that allows us to do is say that x is equal to b times 1 minus r to the n plus 1 divided by 1 minus r. And that's our formula. That's our formula for a finite geometric series. So what that brings up is the question of what happens to x as n goes to infinity. And we're not going to use formal limits here, we'll just use some informal reasoning. If you want to see the formal version, you'll have to take a course in calculus probably. What we're going to do is write x as the sum of two terms, because we have two terms over here. We have b over 1 minus r, and we have minus br to the n plus 1 over 1 minus r. And I'll split it up this way because in terms of b and r, the first term is constant, and the second term, it depends on n. So it'll change as n goes to infinity. What we're going to do is do casework on r. And there are a few possibilities, because what r is with respect to a certain interval that I'll mention in just a second, that really determines whether this sum converges or diverges, or doesn't do either. But it's a matter of whether it converges or not. So we can see that if r is greater than 1, then b times r to the n plus 1 over 1 minus r, it goes to infinity, because the bottom is constant, but the top here, it'll go to infinity. So we have divergence. If r is less than -1, then b over 1 minus r is a constant, so we don't have to worry about it. But we have a factor of r to the n plus 1, and this fluctuates between going to infinity and going to negative infinity depending on the parity of n, so whether it's even or odd. But either way, we have non-convergence. So what we're left with is the following interval. We have -1 is less than r and r is less than 1. For r equal to -1 or to +1, you can analyze those by yourself. Neither of those converge, because this one we fluctuate between two numbers, so we get b minus b plus b minus b and so on, and that does not converge. And for this one we get b plus b plus b and so on, which also doesn't converge. So really we're left with this interval over here, and in that interval, b times r to the n plus 1 over 1 minus r, it goes to 0, which means what we're left with is b over 1 minus r, which was the first term. And that is the formula for the infinite geometric series in the case that we have the absolute value of r is less than 1. That's equivalent to this condition. Okay, thank you for watching, and I'll see you next time.